Okay, number 4 was tricky for a lot of students. Lenny had a rectangular deck that was 12 feet by 14 feet. Okay, so the original deck was 12 feet by 14 feet. And he now has a new deck. This one's going to be a bit bigger. He wants to increase the length, which is originally 14 feet, and the width, which was originally 12 feet, by the same amount. So that means if I'm going to be increasing the length, let's say I'm increasing the length and the width by 2. So we'd be 14 plus 2 would be 16. 12 plus 2 would be 14. So I don't know that I'm increasing it by 2. I know I'm just adding it by the same amount. So I'm going to call this same amount variable x. And you can choose whatever variable you want. But I'm going to be adding 14 plus x and 12 plus x because I'm adding to the length and the width. And then it says, so he wants to increase the length and the width by the same amount. So we got that part. And add 120 square feet to the total area. Okay, so we don't know that, well, we could calculate the total area of this. So the area here would equal what? 14 times 12, right? The length times the width. Well, here we want to add 120 square feet, which is just feet squared, to the total area. So for the new deck, my area, which was originally 14 times 12, I want to add 120 square feet to that. So that means that I know that the 14 times the 12, this was at my area. So now I have the length times the width of this new deck is going to equal this area that I have here. So I have 14 plus x times 12 plus x is equal to my 14 times 12 plus 120. And with this equation, I could solve for x. So it didn't actually ask us to solve for x, it just said which equation can be used to determine how much Lenny should change the dimensions of his deck. And that gives us answer choice D.